Okay, today we are doing problem number 4.3. It's on the tension member. I will read out the problem for you guys. Problem says calculate the strength of ISA 40 into 25 6 mm when used as a tension member with its longer leg connected by first case 14 mm diameter rivets and second by fillet welds. So let's start to solve the problem for the first case, that is use of rivets or using the rivets, right? So before that I will draw the picture. So this is the set plate to which this angle is connected by the rivets. This is 14 mm nominal diameter. We have to find out the gross diameter. This is 6 mm. This total until the end of this will be 40 mm, and this is 25 mm. So we have to find out the strength of the ISA 40 into 25 and 6 mm is the thickness. So let's try to solve for the first case, that is by using the rivets. We know that first of all we need to find out the diameter of the rivets. So gross dia of rivets. So you have to follow the table. So again it is from the chapter on the fastener, so it will be 15.5 mm. This is the first case. Then we have to find out the net sectional area of the connected leg and the outstanding leg. So this is as per the procedure for the tension member, wherein we are using the single angle connected to the gusset plate. So formula says that K1, so we have to determine the K1 is equal to 3A1 divided by 3A1 plus A2. So A1 is for the connected leg and A2 is for the outstanding leg. So these are the formulas given in the procedure for the tension member, and from this, if you know the K1, we can find the A net. So A net will be given as A net will be equal to A1 plus K1 into A2. So this is our objective. We have to find the A net to find out the strength of the member. So let's start one by one. First of all, find A1. So already we have the gross diameter. So gross dia, I will write GD is equal to 15.5 millimeter. So we know as per the formula A1 will be equal to 6 into 40 minus 6 by 2 minus 15.5. So this is for the connected leg. So this is the height of the connected leg. Then this is T by 2, that is thickness by 2, and this is gross diameter. So we have subtracted this T by 2 and the gross diameter from the height of that connected leg, and this is for thickness of that connected leg. So this will give us, so it is standard formula. So if you see that, you will come across that formula. So by this A1 will come equal to 1.29 millimeter square. Then our job is to find the A2. So in case of A2, again this is for outstanding leg, 6 into 25 minus 6 by 2. So here this is again thickness of that leg, this is the total length of that leg, and this is T by 2. So we don't have here gross diameter or for rivets because no rivets are connected to the outstanding leg. So this will come to the 132 millimeter square. So once you have these two things, then we can find out the K1. So just plug in the value 3A1 divided by 3A1 plus A2. So our K1 factor will come to, if we do the calculation, 0.746. So once you find the K1, our job is to find out the A net. This is the most important thing. A net So the area which will actually transfer the force or bear the force is required, or the load is required, so equal to A1 plus K1 into A2. So this, if you plug in the values, this will come to the 227 millimeter square. So this much area will be used to transfer the force or the loads. From this we can calculate the strength of the tension member. So next is, our final job is to find out strength of the member. So once you know the A net, so it will be simple trace or permissible trace and A net, right? So for this kind of tension members, again you go to the table and find the value for the shape trace or the permissible trace for this kind of uh, so it is particularly table 4.1. so table 4.1 I'm writing here. From here this trace will come, table 4.1, and again value, and as usual net, a net we have calculated as. So this value for the angles uh, having the thickness up to 20 mm, this value is, trace value is 150 Newton per millimeter square or megapascal, right? This is Newton per millimeter square into our A net is calculated already, that is 227, right? This is again in millimeter square. So this will give us value, because this millimeter square will cancel to each other, so we have the value in Newton. So to make it kilonewton, so we have divided this entire quantity by 1000, and the strength of the member when connected by the rivet joint finally will come to the 34.05 kilonewton. So this is all about uh, the strength, or calculate the strength of the tension member when we connect the tension member by using uh, the rivets. Okay, before we move to the second part, that is for the weld or welded connection, I have one correction. So I said A1 maybe 1.29 or 12.9, I don't remember, but it should be 129 millimeter square. So just take out this confusion, so that you can use the correct value. So now we will move to the second part, that is the we have to find out uh, the strength of the ISA when it is connected using weld. So when we are using the weld, there will not be any rivets, right? In that case, the values of A1 and the A2 will change. So now A1 will be equal to, just 6 will be there, then 40 minus 6 by 2. So this is for the connected leg. So again this is the connected leg length, and this is T by 2, and there will not be any rivet, so we are not going to deduct cross diameter, and this is again thickness of that leg. So basically it is thickness, and this is height or the length, whatever you want to call, and we are just, as per the formula or the procedure, we are taking minus T by 2. So A1 will become here 222 millimeter square, right? Then we have to find out the A2, that is for outstanding leg. The same procedure will be there, 6 into, but here length of the outstanding leg is 25 minus 6 by 2, that is T by 2. So this will come to 132 millimeter square. Once we have A1 and A2, our job is to find K1. The formula is again same, 3A1 divided by 3A1 plus A2, right? So plug in the values and you will get this factor that comes to 0.835, right? Once we have these values A1, A2 and the K1 for the welded connection, job is to find out net effective area. So A net, again same formula, A1 plus K1 into A2. So just plug in values, and you will get net equals to 332 millimeter square. So once we have that, finally we have to find out the strength of ISA, Indian standard single angle, given angle. So again it will be permissible trace. This is 150. To make it kilonewton, again divided by 1000, and area, that is A net, calculated 332. So finally the strength or the force or the load transferred by this ISA as a tension member when connected to the gusset plate by welding joint or welded joint come to 49.8 kilonewton. So that's all about for designing this ISA member as a tension member. Thanks.